That's better. Is that okay for you guys? Okay, much better. So we're actually going to revisit this photo later, but have you guys heard of the Hubble Space Telescope? Save Hubble! Actually, Hubble had some issues back in, I think it was '06, and they had to decide whether to, and that was when we were having the international, or the shuttles, the space shuttles, we weren't going to use any more space shuttles, and so they decided to go ahead and still maintain the Hubble Space Telescope. It's been up there a while. But anyway, this is a part of the sky where there's nothing. Like if we were to go out tonight and use any telescope I have, it'd be nothing. With the Hubble Space Telescope, it can see all this. So these are not stars, these actually are galaxies, in most cases, galaxies. And like we already talked about, you already know this part. And I was just thinking tonight, I'm going to probably have to put a test question about this, because this is a cool thing you ought to know. We actually orbit you guys told me, sun, right? And we call that the solar system. Okay? And we already said that most stars, like the sun, have planets orbiting them. Okay? And our sun is a member of the galaxy, exactly. Our sun is just a member of the Milky Way galaxy. We'll talk more about the Milky Way galaxy later, but it's a spiral galaxy. We're on one major spiral arm. And actually, our galaxy belongs to a group of galaxies called the local group. Okay? And you would think somebody could be more creative than this. So we have galaxies together in the local group, and then we have groups of galaxies in what we call the local supercluster. Okay, he's like, really? Could you not use a word other than local? That's my point. You know, I always think of that. What's that show, that sitcom where everybody knows your name? The Bar.
Cheers.
Cheers. Thank you. I was thinking that one. Like, but anyway, our cosmic address. Okay, so as you might imagine, there's a fair bit of distance from the Earth to the Sun. Okay, there's a fair bit of distance from the Earth to Pluto, right? But there's even more distance from our star, the Sun, to another star. So we can't talk in terms of miles or kilometers. We have to talk in terms of something else. So in astronomy, you see up here, and I know it seems like small writing. It is too small of writing for most PowerPoints. But I kind of, this semester, decided to take my PowerPoints and instead of making them 6 per page, when I printed them out, making them 2 per page and putting a lot of words on them. So we'll see if we like it. Okay. So 2 big ways, no pun intended. We talk about distances in astronomy. There's the astronomical unit, AU, okay, and that is the distance between the Earth and the Sun. And then there's the light year. Some of you, it's important that you kind of get under your belt, what in the heck is a light year? Well, in order for that to make sense, you need to know that when I go over here, okay, I'm going to turn this off. When I go over here and when I turn it on, electricity does its thing, well, electricity does, okay? It goes to the light bulb, and that light bulb begins to glow. And then what happens when the light bulb glows is, and we'll talk more about this later too in Chapter 5, when the light bulb glows, little packets of energy called light photons, doesn't that sound Star Trek-ish? Light photons come to me, or come to everybody actually. Okay? And they travel at 186,000 miles a second. So you're like, dude, that's really fast, right? So that's why when you turn it on, you're like, it takes no time. But let's just say you were in the business of being able to do such things, and somebody 1 light year away from you, a distance of 1 light year away from you, distance, that's light years of distance. Let's say they were 1 light year away from you, they turned on their light bulb, those little photons would leave it, and it would take 1 year to get here. Okay, 1 light year. Okay, so a light year is a long, far piece. I can't remember what it is in terms of. Have you guys ever used the Google to like convert things? Check this out. Let's see. What we got to do is find the Google tool. Find any Google. And say convert 1 light year equals. And let's see how many miles it is. Can't remember. I'm not that geeky. Convert, because now I'm curious, right? Convert. Come on, wake up. You're like, if she does this for every slide, we're never going to get through this. See how it's filling in? It's like, so what do you want to convert 1 light year to? Well, let's convert it to miles. Google's so smart. Thinks it is so smart. So actually, if this could really, this whole Google thing, you could really kind of help you out in your homework sometimes. Okay. Oh, come on. Usually it. There it is. Okay, this number down here. There we go. Whatever that number is. And this is a decimal, okay? So that's how many miles are in 1 light year. There's the decimal starts here. Okay, that's how many miles in 1 light year. The nearest star is about 4 light years away. The nearest star. That's how many miles it is. So in other words, 4 light years, okay? So here's the deal. When that star does its little beaming of photons, it takes 4 years for that photon to reach us. Just like when I turn that light bulb on, it comes right like that, 4 years. Here's one for you, because we're going to talk about this in this unit. Can you see where that star that's 4 light years away, when the light finally gets to us, how much has that star aged? Well, one way to look at it, the light we get, this is probably a better way to look at it, the light we get from him right now, him or her, okay, actually is what that star looked like 4 years ago. Does that make sense? Because the light, the information, that's what light is information. Okay, the light took 4 years to get to us, and so it's like 4 years old, the information we get. Yeah. That's what I was trying to say. Okay. Inquiring minds, what to know. So astronomical units is the average distance between the Earth and the Sun. And it has to be average because honestly, we're going to find out soon tonight that, so we know that it's coming up. We know that you guys told me that the Earth goes around the Sun, right? And we're going to see actually it's not a circle. It's kind of an oval. Kepler found that out. Okay, so it's not really a circle. It's kind of lopsided. The Sun is lopsided from the orbit. So sometimes the Earth is closer to the Sun than others. Okay, so that's just an average distance. Okay, where were we? So to finish up this slide, one last thing I want to say about distances is not necessarily that star, which is Alpha Centauri, is the star I was talking about, the closest star. Okay, if you saw the movie, what movie? Come on, help me about the whole movie thing. What was it with the?
Avatar.
Thank you, Avatar. Exactly. That was based upon that Alpha Centauri thing. Okay, so switching gears now. Actually, I'm hoping this semester you'll be able to see this little fuzzy patch. I have binoculars. Actually, you can, with binoculars, see that little fuzzy patch. That is the Andromeda Galaxy. That fuzzy patch, made bigger, looks like this. Okay? The Andromeda Galaxy. The Andromeda Galaxy, like our own, and actually the Milky Way Galaxy is playing a nice little gravitational dance with Andromeda. Milky Way and Andromeda, dance partners. And actually, Andromeda has a couple of little dwarf satellite galaxies. So it's a small world.
Eventually, aren't they going to collide?
Yep, they are. They are. And they call it I've heard it described as cannibalism when they collide, and the little one gets eaten up by the big one. But maybe you meant Andromeda and Milky Way?
Yeah.
Yep, they are going to collide too. But there's so much distance, you probably watched the same documentary I did, I don't know. There's so much distance between the stars that we'll see it in the nighttime sky. Well, we won't be here to see it. But our nighttime sky will get really bright with the stars from Andromeda, okay? But no collisions are likely to occur. Okay, so distance-wise, 2.5 million with an M, 2.5 million light years away. That's how far away that galaxy is. The Andromeda galaxy is part of our local group of galaxies. Not so surprising since we're gravitationally hanging out. So this actually, if you have the slides, okay, you guys don't have this, do you? I went ahead, I have this right here. So it's not, I didn't tell you, but I took all the math out of this. There's really no math in it. But I do want you to have an idea about numbers that are packed up in what we call scientific notation. How many people are kind of familiar with scientific notation? Okay, kind of. So because you're going to see it here and there, because in astronomy we have big numbers and we have a few small numbers too, but mostly big numbers. So I kind of wanted to do this kind of little primer. Scientific notation. Just want you to kind of get a sense for them. So this is the way I kind of summarize scientific notation. There's like it's written, there's like a left number and a right number. There's a left decimal number, it's called the coefficient, and then it's times 10 raised to a power. And that power is how many times you move the decimal place over. If the 10 raised to a power, if that's a positive number, if that power is positive, it means a big number. If that number, that what we call exponent of 10, 10 raised to a power, is a negative number, that means it's a small number. So just for kicks, if you want to, let's go ahead and kind of do these. Let's pack these numbers up so you can do them on your own or kind of watch. Okay. For this first one up here, if I were to ask you where the decimal is, you might tell me here-ish. Does that seem right? The decimal's kind of over there at the end. Okay. Usually when I teach, because this makes a difference that it's not specifically written, I'll put a little dot, dot, dot around there to say it's just what we call implied. It's just there. We just all kind of know it comes after that last zero. So here's the packing up part. So let's go ahead and move this decimal. I guess I get my left and rights mixed up. We're moving it to the left. Thanks. The number of places that we need to get a number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. One more right there. Okay. So that my first number is going to be, what, 1.23 times 10 to the 10th? Does that make sense? Because I moved it over 3, 6, 9, plus one more, 10. That look good? Because you're going to see some numbers in astronomy that are packed up in scientific notation. And I'm hoping when you see that times 10 raised to the 10th power, you're like, oh, dang, that means I would move the decimal place over 10 places to unpack that number. Let's see, the other one is kind of similar, isn't it? Okay, so the implied decimal's right there. Move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that looks like I'm going to have, what, 5.9145 times 10 raised to the 11th power. The next one, the exponent of 10 won't be so big, will it? There's the implied decimal, 1, 2, 3. Okay, so my coefficient, or my decimal number, is 4.3 times 10 raised to the third, because I moved it over 3 places. Here's 1, 1, 2, 3, 4. Looks like for that last one in that column, I need to move it over 5 places. My decimal number is 1.01 times 10 raised to the 5th power because I moved it over 5 places. Okay, let's do some small ones. So the difference between the big one and the small one is like I said, I get my left and rights mixed up, so I don't memorize this. I just know I need to move the decimal, and then my power of 10 is going to have a negative there. Okay, so this one, I'm going to move it 1, 2, 3, 4, 5. I'm going to only move it 5 places. Because if I move it 5, oh, I did the second one, sorry. I didn't skip the first one. For the second one, if I move it 5 places, I get 5.006. And that's going to be my coefficient. Times 10 to the, what did I say, 5?
-5.
Thank you, -5. Perfect. Are we good with that? Let's just do the last one. No, let's do the first one, because that's like the craziest one. And we done. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9 places. So and that gives me a coefficient 4.721 times 10 to the -9th. So the more negative the power of 10, the smaller it is. Okay? There's your quick and dirty scientific notation stuff. All right. So we could actually use time as distance. And no, you don't have this slide either, but you do have the next slide you do have. And I kind of want to kind of liken this to everyday things. Let's just say your car, you know your car always goes the same speed, 60 miles per hour. It always goes 60 miles per hour. And let's just say you tell somebody going 60 miles per hour in my car, I can get there in 30 minutes. Okay? 60 miles per hour. Do it this way. 60 miles in 1 hour. Okay? This is what we call the factor label method. 30 minutes is 1/2 hour. In 1/2 hour, okay, to get there, that means it's 30 miles. Does that make sense? Okay. So basically, we are taking a time, which is 30 minutes. We're taking how fast you know you go, which is 60 miles per 1 hour. And knowing that in 30 minutes, you will go 30 miles, right? Let's bump it up a notch. Let's say you have a faster moving car. Okay. Let's say your car moves 600 miles per hour. Okay. 600 miles in 1 hour. Okay. And let's say again, says I can, what is the distance I've traveled in a half an hour or 30 minutes? Like 5 hours. Okay, our hours cancel. If we take 0.5 times 600, we get 300. Wow, 300 miles. Well, you know where I'm going with this. Is let's say you're going, what is that? 6 million miles an hour. Okay, and in 30 minutes you will have traveled what? 3 million miles. Yeah. So you do have this slide now. So I said how fast light travels. And this is kind of getting back to when we see light from a star that's 4 light years away, it took 4 years for that light to get to us. But we can also use that then as a light year as a distance. Light travels at a certain speed. Okay. So light from our moon, because of its distance and because how fast light travels, light from our moon takes 1 second to get here. It's 1 light second away. Our moon is 1 light second away. It takes 1 second for light to get here. The sun is 8 light minutes away. It takes 8 minutes for light to get to us. Seriously, the brightest star, because it's close and because it's bright, relatively close, is 8 light years away. It takes 8 years for that light to get to us. The Andromeda Galaxy, we said, was 2.5 million light years away. It takes 2.5 million years for that light to get to us. Okay? So here's where we can kind of, that packing up numbers in scientific notation, or better yet, looking at numbers that are in scientific notation and getting a sense for what they are, this is where this can come into play. So if we unpack, for instance, that last number, this right here, like 2.4 times 10 to the 19th kilometers. Like, all right, yeah, how far can that be? Well, if we unpack it, it looks like this. 2.4, and to unpack, we're going to make it bigger. We're going to move it over 19 places. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Decimal place. Put zeros here. And that's how many kilometers away that is. So again, I just thought I wanted to take the time this semester and to kind of look at scientific notation. Well, that's a lot of kilometers. Oh, better put units here. Okay. All right. So, like I said about the star that's 4 light years from us, when we see that light, it was as that star was 4 years ago, because that's how, when it left to come see us. One of the things I just get tickled about is when you look at objects like the Andromeda Galaxy through a telescope, I mean, photons, they go in your eye and that's it. So it took 2.5 million years for those photons to get this far, come through Earth's atmosphere, be collected in the telescope, go back up to a focal point, then snap into your eyes and be interpreted by your brain. 2.5 million years. I'm like, dude, really? I just think that's amazing. It just makes me appreciate them even more. Okay. So let's take a break. I got 7:23 or so. Let's take a 10-minute break and come back, because the next couple slides I want to do together. And then there's not a whole lot left for Chapter 1, and we'll start in on Chapter 2 after that.